Okay, humans, so we're going to talk about probability today. Probability can take all different kinds of forms, but the big two buckets we have are simple and compound. We're talking about simple first, because compound obviously gets complicated. Simple probability. This is when you have a simple coin flip. When you have options or heads or tails. So probability, generally speaking, is the chances of it happening over the total number of opportunities. So let's say I wanted to get the probability of heads. I would take how many chances are there of getting heads? 1 out of a total of 1, 2 chances. So the probability of getting heads is 1/2. Probability of tails is also 1/2. That's the easiest example to think of. Now, things like a dice roll. Options are 1, 2, 3, 4, 5, and 6 on a standard die. That doesn't account for D20s or D8s or D10s or D100s that you would play in D&D. But let's say you want to get your probability of getting a 1. That would be 1 out of a total of 6. Probability of getting an even number, there's 1, 2, 3 even numbers out of a total of 6, which is like saying 1/2. You can simplify probabilities the same way you could simplify fractions. You also could say probability of not a 2, it's a symbol for other than. Probability of something other than a 2, there are 1, 2, 3, 4, 5 things that are not 2 out of 6. You also say something like that. You also think about cards, like a standard deck of cards. So the probability of a heart, let's just say. There are a total of 52 cards in the deck if we don't count the jokers. Probability of hearts, there are 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. That's 13 out of 52, or 1/4. And we know 1/4 of the deck is hearts, 1/4 is spades, etc., etc., etc. So that's simple probability. Doesn't go very far. Now, compound probability is where people tend to get a little bit touchy about this. Now my wife is pouring popcorn and it's in a plastic bag and it's very loud. She's spilling it everywhere. It's amazing. Popcorn flung across my screen. So this is the popcorn that was just flung across my screen and it's delicious. So compound probability can be split into independent and dependent. Independent is when one event has no effect on the next event. Dependent is the opposite, where one event has an effect on the next. And that's the big distinction. So, independent. An example of this would be a repeated coin flip. So, the probability of getting heads followed by heads again. I can think about it like this. My first flip, my options are heads or tails. My second flip, from the first heads, I can get a heads and a tails. From the first tails, I can get a heads or a tails. The thing that makes this independent, the first one, whatever I get, doesn't necessarily affect what I get from my second one. It doesn't make it more or less likely. I don't erase the heads when I get it. So the chances of me getting heads than heads are right here. That option, that's 1 out of 1, 2, 3, 4. There are 4 potential events, 4 potential outcomes, and one of them results in heads. Okay. Something else would be repeated dice rolls. Stuff like that. So now the way you do this quickly, the chance of getting 2 events in a row. So probability of getting a 1 and then a 3 on a dice roll. So the first probability was 1 out of 6, like we did on the other side. The second probability is also 1 out of 6. To figure out the total probability of that exact combination, I would do 1/6 times 1/6 and get 1/36. The chances of getting the exact combination are 1/36. To apply it to our head-to-head situation, the chances were 1/2, then 1/2 again. 1/2 times 1/2 is 1/4. So it does work out that way too. Another one that comes up a lot is when there's replacement. This is a word that comes up a lot if something is replaced, or if you're pulling marbles out of a bag and then they're replaced. So if you have a red marble, a blue, and a yellow, these are all marbles. You can use cards, you can use anything. The chances of getting a red followed by another red with replacement. This is the key idea here, which means once you pluck your first red, you put it back in the bucket, and then you pluck again. So chance of getting red were 2 out of 1, 2, 3, 4, 5 the first time. It's then put back in, and the chances are 2 out of 5. Again, there's still 5 in there, and there's still 2 reds in there. This would be a total chance of 4 out of 25, which is in simplest form. Okay. Now, this is a very different world than dependent probability. Dependent probability is when something affects the next one. Usually is when things are not replaced or the word is often removed. So in that same marble example, if you had red, red, blue, blue, yellow, the probability of getting a red followed by another red without replacement, the chances were 1, 2 out of 5 on the first pluck. But then, because we already plucked a red out, that essentially eliminates one of them. Chance of getting red again are 1 now. There's only 1 red left out of 1, 2, 3, 4. I've taken 1 out of the bag. So I'm left with 4 in the bag and only 1 of this red. So I can take that 2/5 times 1/4, and I get 2 out of 20, or 1/10. That's how the replacement and dependent probability works. This can also be applied to if you're picking things out of a bucket for prizes. You wouldn't put the prize back. That would be an example of dependent probability. But that's how dependent versus independent probability works. But the big role for common probability, it's going to come down to multiplying your probabilities. It just depends on how you do it. The how depends on if it's an independent situation in which there is replacement or something doesn't affect a second, or dependent, where there's not replacement and things are pulled out of the whole pool. Hope that helped. Yeah, have a great time.